The next part of our presentation will be going over troubleshooting tips. It's our guide to help technicians in solving HMA mix problems they might encounter in the field. Next slide, we're going to meet the team. That'd be me, Brad Curry, with Milestone Contractors. I started at Milestone in 1991, so this is my 30th year here. My role is a quality control manager for Milestone in the Indianapolis market. And prior to working for Milestone, I worked for NDOT in the Crawfordsville district from 1985 to 91. So total time 36 years that I've had in quality control. This third slide here is definition of quality control. The main thing of quality control is when you inspect it and you sample it and you test it, you determine based on all those samples and tests whether or not you need to make changes to either achieve or maintain a certain level of quality for your product. Care, accuracy, precision. It's an acronym that we use, CAP, to describe basic principles. And when you're getting your samples and making sure it's an accurate sample so you can make decisions of whether or not you need to make a change in your mix. HMA is accepted by how close these properties are to the DMF. So the properties that we look at are mat density, air voids, VBE, and binder content. So together between the VBE, which is 35% of your pay, mat density, and your actual course in the pavement are 35%, air voids are 30%. So those are things that we look at and determine whether our mix is okay or not. This slide shows some of the most common QC tools that we use. Probably the most common one is knowing our gradations for stockpiles, mixtures, wrap. Guy always said you got to know where you're at to get where you're going. So know what's in your stockpiles, know what your gradations are in your mix, know what your gradations are in your wrap piles. Binder content, make sure everything's running good. Whether or not you're using an extraction method or ignition oven, both methods are good. It's got to know that your asphalt content is correct. Bulk specific gravity, your peel heights. You know, one thing I always like commenting on this slide or this bullet point is always use the same mix weights. Whether you use like 5,600 grams or 5,700 grams, always use the same weight. Then that way, because it is volume, if you use the same weight, you can tell pretty well where your air voids are going to be based on your height of your peel. Max gravity. Max gravities are just your loose mix. That will that test along with your compacted pills to tell you where your air voids are. And don't forget your eyes. Your eyes are a real common QC tool. Something doesn't look right, it's probably not right. So pay attention and point it out. The next three slides we'll look at general relationships. The first slide here is with properly looking at air voids. The two tests that go into determination of air voids are your GMM and your GMB, which GMM is your rice, GMB is your compacted pills. The equation, the GMM minus GMB divided by GMM, that will get you what your percent air voids are. The factors that go into the change in air voids, binder content, absorption values, which is absorption values, when that changes, that has a big effect on air voids. So, good rule of thumb: absorption, binder content. Now, just remember absorption. If you have 0.5% more absorption, you got a 0.5% less asphalt. So, a tenth of asphalt is equal to about 0.25% air voids. So just keep that in mind. Gradation, keep an eye on your gradations. It has just a slight effect on it. Specific gravity, if you're changing specific gravity, it will have a huge effect on your properties. And binder content with your pills, again, just keep in mind the binder content when it fluctuates a tenth of asphalt, it will fluctuate your air voids 0.25. The second thing we'll look at is VMA, your voids and your winter aggregate. There's 5 things that really go into what affects your VMA. It's gradation, shape, texture, strength, and compactive effort. Um, so, and what type of effect that has on the mix is what we need to find out. Good rule of thumbs that I use anyway are for gradation, your primary control sieve. Typically, most mixes a 4% change on your primary control sieve will impact your VMA by 1%. It's kind of a good rule of thumb that should work most of the time. Uh, as far as your 200 is on gradation. Its impact on VMA is about 1 to 1. So a 1% change in your 200, high or low, will change your VMA 1%. Particle shape, the more product is cubical, the more impact it will have on VMA. Uh, you know, Compared to a round particle that will not have that, will collapse VMA. Compactive effort, that's mainly on your rollers, um, or your gyratory compactor or your Marshall hammer in the lab, depending on what your level is, will have an impact. Aggregate strength, this will be mainly if you're using an aggregate that's not very strong. If it breaks down, it's going to have a negative impact of VMA. So, if it breaks down, particles get finer, it creates more dust. That's going to collapse your VMA. So you need to know what um, sources have a weak aggregate structure and how it's going to be a negative impact on VMA. Binder content, I just put it on here. By calculation, binder content's a 1 to 1 effect on VMA. So if you have, for instance, a tenth of asphalt um, less, it will have just a tenth impact by calculation on your VMA. So very little. VMA, it's all in your aggregate structure. The third thing we'll look at is VBE. That's the volume of effective binder. VBE it's VMA minus your air voids, and it's another factor that we get paid off of, so we pay attention to it. Um, the impacts of VBE happens with gradation, binder content, absorption. Uh, so mainly the same things that affect VMA obviously affects VBE. So the same rules of thumb apply. If you got low VBE, you definitely need to make a gradation change. If you have high VBE, you, you can make a gradation change. Just remember, you make a gradation change, you're changing both VMA and air void. So if you have high VBE and you need to make a gradation change to get your air voids up, your VMA goes up, that difference is going to get greater. So the only way to close it up is to add binders. So if you have high VBE, you're going to make your gradation change plus add binder. So that should be how you can control VBE. This slide shows the difference of compacted pills versus loose mix. Just a volumetric picture. What makes up a compacted pill when you pack it up? You obviously can see the binder and the aggregate in the mix. Also, what's in that pill is your percent of air. And loose mix, when you're just running your rice sample, your GMM, when you run it, you have it's no air voids in it. It's all aggregate and binder. The next few slides will discuss what happens when certain things happen. In this case, on this slide, what if GMB goes up? Your GMM is okay. How does that affect your VMA? How does it affect your air voids? And how does that affect your binder? So we'll have to discuss that, give it some thought, and take you to the next slide. So if your GMB goes up, your GMM is okay. How does that affect your VMA? Well, your VMA is going to go down. And just kind of keep in mind that when you're looking at your differences between GMB and GMM, about a 0.025 change. In this case, if it goes up, it's going to bring your GMB and your GMM closer together. 0.025 is going to be about a 1% change in VMA. Also, what's it going to do with air voids? If your I stays the same, air voids and VMA will move in the same direction. So a 0.025 change, your air voids will go down 1% as well. So both of those will go down. Most likely, if your ice is okay, your binder is going to be okay. So the net effect on common scenario number one, if your GMB goes up and your rice is okay, your GMM is okay, your VMA will go down, your air voids will go down. Most likely, your binder content will be fine. So the cause, remember, in VMA, it's all in your ag structure. So make a change to your gradation of your materials. The second scenario is if your GMB goes down, your GMM's okay. What effect does it have on your volumetric properties? It'd be the other way. From the first scenario, your VMA is going to go up, your air voids are going to go up, because remember, VMA, air voids should move in the same direction every time. Binder content's probably okay. So again, your ag structure, you need to make a change in your ag structure to get your VMA up. The third scenario is what happens when your GMB, your compacted pills, goes up and your GMM, your rice, goes up. Probable effect, most likely your VMA will go down. Air voids, kind of hard to say. Most likely if the GMB goes up, rice goes up, most likely your air voids will stay the same from wherever they're at. So because there's difference between GMB and GMM, as long as that doesn't change, the air voids won't change. Binder probably will go down. Usually when you have higher GMM values, most likely you have lower binder contents. Could be actual binder or could be affected binder. So your probable cause, ag structure, most likely if GMB and GMM both goes up, probably an ag GSB has changed and it has gone up for them both to go up together. Air voids, I say, kind of unknown, but most likely stays the same from where it's ever or where it's always been. And then on binder, your binder, if it goes down because your rice goes up, most likely it's either low binder absorption, which mainly is the low effective binder. So you're having more absorption in your mix, which gives you a lower effective binder, which will affect your rice and your air voids. So this slide is the opposite of the one before. It shows what if your GMB goes down, your GMM goes down, your the effect on your property is VMA is going to go up. Air voids will probably remain the same. Binder content will probably go up. And why is all that? Your probable causes. Since GMB and GMM both went in the same direction, probable cause is your ag gravity of your blend is probably has changed, probably gone down. Air voids, I say, should remain pretty constant. Binder content, if your GMM goes down, most likely your binder has gone up, probably related to binder absorption. So your effective binder um, has increased and caused your GMM to go down. And the last scenario is, what if your GMB, your compacted pills, are greater than your loose mix, your GMM? Probable cause? Well, it's time to panic. Most likely it's a test error. So in this particular case, just go back, get you another sample, and run your GMBs and your GMM again to verify the results of that mix. Mix gradation control. This slide shows some sieve sizes that you probably ought to start looking at for individual components of your mix. Dealing with coarse aggregates, kind of start with a half-inch sieve. That's a sieve that has a lot of material retained. Most likely, if you're having some mix issues or varying mix issues, most likely looking at the half-inch sieve for your top part of your aggregates. For just looking at the difference between coarse ag and fine ag portions, mainly looking at segregation, and I'll go into a couple slides into that later, but look at the number 8 sieve and the number 4 sieve, monitor that sieve. Remember, keep in mind, I said earlier, the uh, BMA, a 4%, if that's the primary control sieve, which typically the 8 or the 4 is a primary control sieve, 4% change on this sieve will cause a difference in VMA of 1%. Then if you're looking at fine aggregates, look at the number 30 sieve. That's a good sieve to look at, whether you're looking at natural sands or stone sands, manufactured sands of some type. 30 sieve, a good variance of that is to, like I say, keep a handle on the 30 sieve, and you should be able to control your fine aggregate gradations. And then the 200 sieve, that's your dust control. Again, the good rule of thumb with a 200 sieve is 1% change in 200 is probably a 1% change in VMA, 1 for 1. This slide just shows a generic view of an asphalt plant. So just showing that starting off with the aggregate stockpiles, you're going to feed your cold feeders, your wrap feeders, and your PG binder grades. Going into your drum, your bag house will You'll control your 200s from materials fed back through the baghouse. Load the mix up into your silos, dump it into the trucks, and send it out to whatever job you're going to. One of the first slides I showed you was looking at QC tools that we use, eyes being one of them, the very last bullet point. Here's where your eyes can help you out. We'll look at aggregate and wrap stockpiles, cold feed systems, mixing and loadout systems, and dust systems. This photo shows the drum plant. On the right-hand side shows the aggregate conveyor belts that feed the aggregates and the wrap into the drum. The drum mixes it with the binder. That's the binder tanks are in the background of the photo, and it mixes the materials, brings it out into the slack conveyor. That's the piece going up that's connecting the plant to the silos, and dumps the mix into whatever silo they need it to that's designated for that mix. And then the trucks come in under scale 1, scale 2, scale 3. Plant operator dumps the mix into the truck and sends it on its way to whatever job that they're working at. So the next few slides will be places to do your troubleshooting for QC. First place you'll start at your stockpiles. 3 bullet points here: segregation, and segregation can be on your coarse ags, just seeing, using your eyes and seeing the difference between fine and coarse in your piles. Handling the segregation from supplier to yard to the mixture. So loader operators making sure they're building their stockpiles correctly, and keeping your materials uniform in your stockpiles before it gets sent to your plant. And contamination, make sure there's no trees growing in your sand piles. I've seen that before. And make sure there's no other debris or contamination from one stockpile from some sand being put into a coarse aggregate, or vice versa, a coarse aggregate getting into sand piles. And that could happen several different places, either by building your stockpiles or by trucks coming in from your ag sources, and maybe material getting held up in the trucks and not getting all the material out. So once you have a good handle on your stockpile yard, materials are going to go from the stockpiles into your cold feed bins. So it's very important to maintain good quality control at your cold feed bins to make sure the right material gets fed into the plant. So we got 5 bullet points here, and properly calibrated. So make sure you spend the time calibrate your cold feed bins to material that you're running out of that bin. Make sure they don't run empty or material bridges. So most cold feed bins have uh, low flow indicators on them, so the plant will know whether or not you run out of material or not. So if you do, stop the plant, let the loader operator throw material back in that bin to get it going again. The bridges, that could be typically your fine sands that have a lot of -200 material in them. They can bridge by sitting in a pile or sitting in your cold feed for 2-3 days. So make sure you have again your no flow sensors are working well, so it knows that the material is being fed out of the bins. Overflow from adjacent feeders. So it's hard to see on this picture, but there's dividers between each of the cold feed bins. Those dividers are put in place to make sure the material from one bin doesn't get spill over into material into another bin. Raw material, making sure the loader operator puts in the right material into each cold feed bin. So that's why it's important not to, if you have, keep your bins um, fed by the same material on all your mixes. So it helps the loader operator out by not putting in the raw material into a cold feed bin. In correction, proportional setup. So making sure before you even get started, you got the right DMF, you got the right percents, double check with your plant operator, making sure that the setup in the plant is what you have set up in the lab. Here are two places that you'll encounter segregation at the asphalt plant, either silo segregation or truck segregation. And I apologize, I've got these two topics switched around, but we'll start in the photo on the left, the truck segregation. You can see this by looking at the truck and physically seeing a difference between what the material looks like on one side of the truck than the other side of the truck. And a good way of finding out what that difference is or how much of a difference it is, just sample from each side. Have the truck get a sample, have the truck turn around, sample from the other side, and you can see what type of difference there is in the gradation of the truck. And then the asphalt plant can put in baffles that could help the segregation coming out of the silos into the trucks to minimize the segregation. The picture on the right is your silos. Um, so from the traverse at the top of the silos coming into, uh, bringing the mix up to the silo, you can have segregation coming in from dumping the material into the silo. A lot of this has to do with maybe an empty silo. If it has a 300 feet down, it could affect how the material separates. So having baffles put in each of the silos kind of helps mix the material up and helps minimize segregation in your silos. This photo shows the dust systems at an asphalt plant. There's 3 bullet points on here. I've got the primary collector, the secondary collector, and the mineral filler bin for dust control. So all these are different ways of controlling the amount of dust that goes into the plant. Like on the first bullet point, primary collector, the knockout box, that's pretty well the difference there would be you got lightweight fines and heavy fines, and it's a good way to look at it. And knockout box causes the heavy fines to go back into the mix, and then the lighter weight ones goes through the bag house and feeds back through at a controlled weigh system to get the dust back in to the mix at a metered weight. The mineral filler, a lot of the smaller plants have some type of a weigh hopper that weighs the fines going back into the mix, and it feeds it back through auger systems with a reverse weighing system, and again accurately puts the amount of dust back into the mix. Why is this important? Like I said earlier, dust is 1-to-1 on controlling VMA. So we want to make sure we have the right amount of dust going into the mix. This slide talks about binder content control and where to look. There's 7 different areas here I have on here. Mix segregation, this is plotting the binder content versus either a number 8 or number 4 sieve, whichever you prefer. And I've got a couple other slides that goes into explaining these. Flow meter calibration. Make sure your meters that's feeding your binder into your plant are properly calibrated. Aggregate moisture correction. Your asphalt plants are set up to where you do stockpile samples and monitor your moisture of each stockpile. The plants are smart enough to you give them the moisture content from the piles, and it takes it away from the aggregate going across your belt scales. And then what it does is it compensates the amount of binder that's put into the mix based on your moisture content. So make sure that's correct. Aggregate or wrap weight bridge calibration. Make sure you calibrate each of those belt scales and make sure they're you've got them calibrated to different tons per hour speeds. Wrap binder content, whether you run extractions or burn samples, make sure you have an accurate binder content of your wrap. Wrap aggregate type. Uh, this mainly gets into whether you have dolomite or maybe even slag in your wrap. Make sure you have it identified, and it may affect your how much asphalt that your wrap may have. And then startup, shutdowns, switch and mixes. These are three areas where you have issues with your samples. And whenever you have a startup, a shutdown, or switch and mixes, that's probably where NDOT's going to get their plate sample at. So make sure you minimize those to eliminate any unnecessary penalties you might have. This photo just shows the actual binder tanks at an asphalt plant that stores your liquid asphalt going into the plant. The next two slides is what I was talking about earlier. It's just looking at your binder content versus your either your passing the number 4 sieve or number 8 sieve, whichever you prefer. When you have this type of effect, it's kind of a shotgun effect. It could be something wrong with the plant, most likely. If the numbers are all over the place, they don't make any sense. So talk to the plant operator, find out how everything is showing up on the reports, and tell them there's definitely an issue with binder content in regards to um, gradation of the mix. In this chart showing binder content versus number 4 sieve, anytime it runs in a linear line like this, then it's segregation of the mix. And so again, talk to the plant operator, find out how what ways you can minimize the segregation coming out of the plant into the truck. I have 4 slides left. This slide is starting off on the right foot. So before you start production, you need to have a good handle on where your gradations are in your stockpiles, whether it's ag or wrap. Make sure you have the correct jam for or job mix formula input into the plant. Double check with the plant operator, make sure those are all correct. Make sure the plant's been calibrated, all the meters, all the scales. Test equipment calibrated. Make sure you calibrate all the equipment in the lab to make sure it's ready for production as well. Before you start that major project, do a trial run. I suggest doing about 100 tons. Sample maybe the third or fourth load of the 100 tons. Don't sample the first or last load. Let the plant get generated and get you a good representative sample. Maybe place it on some type of a commercial project that is not as high profile as an NDOT project. Just keep in mind cost of a trial versus the cost of material removal is there's no comparison. So spend the extra time, run a trial, and be prepared when you start that major project. There's a lot of tips that you can do that will help you. I've listed 5, some common tips that should help. Retest to verify results as needed. Eliminate the obvious first. It saves you time, and when you're running, 300-400 tons an hour, time is at the essence. Be careful not to overreact. So if you need to, resample again and just to double check your numbers. Keep track of all your changes so you can find patterns. Where you've been helps determine where you go. And gather as much data as you can before making decisions. Again, it's good to retest, make sure your data is correct. You don't want to make a change unless you're sure of that change. Well, this concludes our presentation on troubleshooting. I wish you all the best of luck and please be safe. Thank you.